Okay, now remember that yesterday we've talked that for every value of z, okay, we can find the area to the rest of them. We call them the phi of the z, which is the same with the probability. This can also be done the other way around. So if we know a probability, okay, that is the area, we can find what is the value of z that makes that probability. Here is what I mean. Let's say we know if the value of z here is, let's say, 1.00. From the table, we know that this means the area to the left of this is going to be 0.6413. But this goes the other way around. If we know an area here, or if it's not 1.00, you can change any value. If you know the z, you can find out the area to the rest of them. But this also goes the other way around. If I know that the area here is, let's say, this is 0.6513. I'm just making some number here. What will be the required value of z here? Okay, so this is how we do here. Mathematically, we're going to, if this value of k, mathematically we say that the k is the inverse phi of 0.7513. This is the formal way. But if you don't want to write the phi inverse, you can read them simple way. We know that the phi of k is 0.7513. Either of this is acceptable. So you can write the first way, k is phi inverse of 0.7513, or phi of k, this is the Greek letter phi. Fine. Okay. Write them like phi. Okay. Phi of k is 0.7513. And then you will read from the table. So from the table here, we're going to read the table. Okay. What is 7513? Read them here until you have 7580. Oh, this is too big. This is too small. So look from this to the right until you find the number. 7517. This is too big. Okay. So this is the closest one. 7486. But we need to add some number. To get 71, so the z value is 0.67. That is two significant figure. The third decimal number is 7513. We are going to subtract with this. We already have 7486. So we need 27 more. Okay, read to the right. Okay, how to get the 27? We don't have 27, we just have 26 and 29. But 27 is closer to 26, so that's going to be 8. Hence, the value is going to be 0.678. That's how we're going to have them here. We're going to find area of 7513. Find the number closer but less than that. This is the one here, 7486. 7517 is already too big. So we get the one closest to it. The z-score, z-value is 0.67. And we need to add 27. That's not 27. We have only 26, the closest. So that's it. So K is 0.678. That's it. It goes vice versa. Any question for this? If no, then let's see a question where we are going to apply this reverse way of reading. For question number 3 there, length of certain type of white radish normally distributed. Let's say this is the length. So the length of them can be approximated with normal distribution means mu and standard deviation sigma. So it's going to be sigma squared. Okay. In this case, we don't know what is mu, we don't know what is sigma. We're going to find them. 4% is longer than 12 centimeter. Mathematically, we're going to write them here. Probability that the length more than 12 centimeter is 0.04. This is how we're going to write them mathematically. Probability that the length is bigger than 12 centimeter is that. Okay, and they say 32%, okay, longer than 9 centimeter. Mathematically, we're going to write them probability that the length is bigger than 9 centimeter is 0.032. Oh, sorry, my bad. 0.320. Sorry. You can omit the unit if you don't want to. Why 0.04? Because the standard way for probability is writing them in in 3 decimal place. Now, let's sketch this. So we know here 4% is small. So this is an area 0.04. That is when the length is bigger than 12 centimeter. While the second one here, when the area is 9 centimeter, that's going to be 32%, 0.320. This is the length here, 9 centimeter. I'm not going to make them into a single graph. Okay? I'm going to make them into 2 separate graphs. I suggest you actually sketch this in your answer paper. So the corrector can see you understand the question. Okay. Unfortunately, the phi value can only be used for the left-hand side. But because the total is exactly 1, we know that the area to the left here is 1 minus 0.04 or 0.960. Same with the one here on the right-hand side. 0.320 is what we know to the right side. Our table can only find number to the left, but the area to the left will be 1 minus 0.320 or 0.680. Now, with the aid of these two data, we can find out the Z value for both. Let's call this K number 2 and this is K number 1. We know that the phi of K number 2 must be 0.960. So K number 2 is the phi inverse of 0.960. Let's read them on the table. 96%. Let's read them on the table. So we need to find 0.96. Read on this table here, the number closest to 960, but not more than. Here, there. Okay. The number we need, 1.8. This is too big. So we're going to here. From here, read to the right. Keep getting until we have closer to 960, but not more than. And here it is. This is the closest we have. 9608 will be too big. 9599 will be the closest. So here, the number is 1.75. But we need one more number here to make it 9600. So we need to add one again, one into this. Now, on the add part, find the one. Now, here it is. That is 1, and that is 1. So the third decimal place is 1. The answer will be 1.751. 1.751. That is for the first number. For the second number, we have the similar case. But then we have the area, the phi of K number 1 as 0.680. So K number 1 is the phi inverse of 0.680. 680, we're going to do 680, same thing here. 69 too big, so 65 here. Go to the right until we have 680. This is too big. Just getting back one here. 6772, but we need to add 28 to get them into 6800. From here, we know the Z is 0.46. 0.4647 will be too big. 46 what? Add 28. There is no 28 here. The closest we have is 29. So we're going to use 29. That's going to be 8. So the answer is going to be 0.468. Okay. That's it. I'm going to stop share, and go back to the tab. So we have these two data now. For the K number 1, this happens to be 1.751. And for the second number, this happens to be 0.468. Now, with that two number, we can find the connection between the Z and L here. We know that the Z is, in this case, is going to be L minus mu over the sigma. Let's put the value here. When Z is 1.751, that's going to be 12 minus an unknown, I don't know, over sigma. This is our question number 1. We're going to have simultaneous equation. For case number 2, with the same formula here, we find out that it is between 9 centimeter and 0.468 in the other scale. So 0.468 is 9 centimeter minus the average that we don't know over the standard deviations that we also don't know. This is our question number 2. We have simultaneous equation. We can solve them to find out sigma and mu. How? First, to avoid having fraction here, multiply sigma to the other side. So we have 1.751 sigma is 12 minus mu. Same to the question number 2, we have 0.468 sigma is 9 minus mu. Now in this case, as we see, the mu can easily be cancelled out. From this, if we subtract, we have here 1.283 sigma is 3. So sigma is 3 divided by 1.283. That's going to be 2.338. So that is the average value. Now we have the average value. Sorry, that's the sigma, that is the standard deviation. Once we have the standard deviation, we can put that into any of the questions, number 1 and number 2. Let's say we're going to put them here. 1.751 times the sigma 2.338 is 12 minus mu. .094 is 12 minus mu. So mu is 12 minus 4.094. That's going to be 7.906. And that's it. That's how we have them here. The standard way in calculating will be three significant figures. So we can write them here. This is about 7.91, and this is about 2.34. That's it. That's how we are going to have them here. In this case, we rely on the knowledge. If we know the area of the graph, we can find out the value of the z-score. That's the understanding we're going to have. Any question up until this? Hello, guys? Any question? Standard deviation. Yes, Brenda?
No,
Yes,
sir, no.
come on.
Oh, no.
No? Oh, okay. Okay. Now, the normal distribution is almost always located near the end because they almost always comment among the highest marks in any paper. They are very useful, and mastery of this is going to open up a lot of opportunities for you. Unfortunately, if we don't get the idea yet, we may have difficulty to understand what the question means. But once we master it, actually it's quite simple. Let's have more and more questions. It's just about the experience. Once we get the experience, we will be very confident and in tackling this type of question. Okay. Now, let's do question number 5. In this case, the question number 2 here, we are going to part 2 of them will be a little will be containing some advanced topic that going to be used the previous one, binomial theorem. Okay. The volume of milk distributed with mean mu and standard deviation 8. So here, let's say we call them the volume can be approximated with normal distribution with mu and standard deviation 8 means we have 8 squared. The n is written with the sigma squared. If we know the sigma, then just square them. Measurement were taken the volume of 900 of these cartons. The 225 of them containing more than 102 milliliters. The probability the volume is more than 1002 milliliter was found out to be 224 over 900. I repeat, probability that the volume is more than 1002 is 225 in 900, or that's going to be 0.25. We are asked to find the value of mu. First question, what is mu? To get this idea, let's sketch them first. We know this is the volume. The volume is having an average value that we don't know. But we know for more than 1002, the value to the right is 0.250. 0.250 is less than half, right? So we're not going to make the line to the left of the average value. We're going to head on to the right because it's less than half. So if this is 0.250, then this is going to be 1 minus 0.250, or it's 0.750. Now, we already understand if this is the value of K here, the phi of K will be 0.75. So K is phi inverse of 0.750. Let's read them from the table. From the table, now 750 is among the special value. Instead of reading this, we can see at the bottom some critical value, important value. For some areas here, the value of Z is standardized. We can have this for quick reference. So here, 0.75 is among some of the special number. We can write the Z directly here, 0.674. You can do calculations yourself normally, but for special values, it's easier to just look at the bottom table here. See, you can read yourself. 750 will be from here, go to the right, there. 0.67. And then we need to add 14. 14 is 13, the closest. We don't have 14. So the closest is 13 and use 4. That will be the same number. but that is take time. It is easier here to just look at the table. Sorry. Now that we have the value of k, we can use this one here. We can use the formula of changing from 0 to v. We know z here in this case 0.674. The value of v is 1002 minus the mu that we don't know, but we know that the sigma is 8. So it's easy then. We can have 8 times 0.674 is 1002 minus mu, and mu is 1002 minus 8 times 6. Okay. We have them here, 996.6. We're going to have them as 997. Okay, that's it. That's how we find the mu. Okay, that is for the number. The question number 2 is about the binomial theorem, and as such, I'm not going to discuss it now. The question taken from the past paper often has more than one chapters in the same question. I'm not going to discuss them now to focus ourselves on the binomial. Okay, I think